Welcome to Carlton's Math Corner. Today we're going to discuss mixed numbers and improper fractions. To begin, make sure that you are ready to take notes as well as record any definitions and sketches. Let's begin with what is a mixed number? What is an improper fraction? Well, a mixed number is a whole number and a fractional part. So for instance, down here, this example here shows that there are three whole pizzas, and then 5/8 of another pizza. So 3 and 5/8 would be a mixed number. Now, an improper fraction is a fraction that is greater than one whole. If you notice, we have more than one whole pizza that we are working with here. The numerator is going to be greater than the denominator because if you count up all these individual slices, so we have 8 pieces in each whole, so 8 plus 8 plus 8, that's 24 pieces, plus we have 5 more. So we have 29 pieces, 29 parts out of, notice one whole amount has 8 pieces. So it's 29 parts out of the whole amount, which was 8. Each one is 8. And so 29/8 is an example of an improper fraction. Now I want you to notice that 3 and 5/8 and 29/8, they both have the same diagram because a mixed number can be changed to an improper fraction, and an improper fraction can be changed to a mixed number. They are both rational numbers, and they're just different ways to write the same amount. And so today what we're going to be doing is changing a mixed number to an improper fraction and going back the other direction as well. And so let's start off with 6 and 7/8. And if I think that first of all, I have 6 whole amounts, and then I have 7/8 of another whole amount. Now, the 7/8 is separated into how many equal parts? Well, the 8 kind of gives it away for us. The 8 represents that there are 8 equal parts, and there's 7 of them that are being used. Now, if I have 6 whole amounts in addition to that, that means I have 6 wholes that have 8 equal parts in them. So how many eighths make up 6 wholes? You're right, 48. Because if I have 8 in every single one of those wholes, if I have 8 in every whole, so 8/8, and then I have 6 of them, that's 8, 8, 8, 8, 8, was that 6? Or 8 times 6, which is 48. And then how many in addition did we have? On our last, we have 7/8 in addition. And so we have 48 wholes plus 7 more eighths. And so really we have 56/8. And another way to write that is 56/8. And so I could actually, if I wanted to write it as a fraction, I could say 56/8. And down here represents that amount. So here's our 6 wholes, and 8, 8, 8 on all of them. And then in addition, we have 7/8. Okay, so what did we really do? How did we figure out, is there another way to figure this out, like to change this mixed number, because really that's what we did. We changed this mixed number to a fraction, an improper fraction of 56/8. And notice what we did was we took how many whole amounts, and we had 6, and we figured out, okay, if everything is separated into eighths, so this denominator is a big clue for us on how many equal parts in each are in each whole. So if I have eighths, I'm really taking the 6 times the 8, and then what do we do last? We added the additional eighths that we had, and there were 7 additional ones. So it was 6 times 8 plus 7. One way to remember this is, I don't know if you've been fishing before, but my family and I, we like to go fishing. And so when we're taking 6 times 8 and then plus 7, it kind of creates this symbol, kind of like a fishing hook. And so I thought of fishing. Well, when a fish goes on the hook, or even if you put bait on a hook, you have to slide the fish through the tip first and then slide it up the hook. And even when you catch it in the water and it still slides, it hooks first on the point and then it slides up. And so what we're doing is we're taking our whole amount times how many equal parts, and that's what this denominator is, and then we're adding additional fractional parts. And so please, this is a great example to get down in your notes on what steps that we are doing to change a mixed number to an improper fraction. So let's do a couple problems together. 5 1/7. What improper fraction would that change to? Yeah, if I take 5 times 7, because there's 5 whole amounts, times 7 equal parts in each amount, plus 1 additional amount, I get 36/7. Nice job. How about 8 9/11? Correct. You take 8 times 11 is 88, plus 9, because there's 9 additional ones, and we get 97/11. Well, what if we have an improper fraction and we want to go back to a mixed number? We can go back. Okay, so take a look at this example. This is 12/5. Do you notice that the denominator means that each whole is separated into 5 equal parts? So if I look at this example, each whole is separated into 5 equal parts, and I need 12 of them, 12/5. So if I take and put together 12 of these fifths, here's 5, here's 10, and then I need 2 more. This is what it would look like. I would be able to put together 1 whole, 2 wholes, and then I'd have a 3rd whole, but I would only have a part of it. And so really this is 2 and how many fifths? 2 2/5. And so we had 2 wholes, and how many fifths were left over? 2. And so the way that we write it as a mixed number is we say 2 2/5. Okay, so let's try it a different way. Instead of creating a model, what if we just used it as a division problem? Okay, we've divided fractions before to change them into decimals. Well, let's use that same knowledge to change it into a mixed number. So let's do 12 divided by 5. So 12 divided by 5, so we're going to take 12 and we are going to put it inside, because remember this is going to fall over inside, and so 12 is going to be our dividend and 5 will be our divisor. So 12 divided by 5, so 5 goes into 12 how many times? Well, it goes in there 2 whole times, because 5 times 2 is 10, and we have 2 that are left over, because 12 minus 10 is 2. Now I know with decimals or with fractions turning into decimals, I stress big time that we can't have a remainder. We have to keep going until we get 0 as a remainder, or we get a repeating pattern. Well, in this case, we are making mixed numbers. We're creating a fraction. So we're going to actually use the remainder to create our fraction. And so 12/5 would be the same as 2 wholes. So 2 whole amounts, that's what we got. 5 into 12 2 times. And then this 2 is our remainder. It is the number of fractional parts that are left over. And then the 5, notice the 5 just stayed the same. That's our divisor, or we call it, it's our denominator. And it's the number of equal parts that our whole numbers are separated into. So 2 and 2/5 would be equivalent to 12/5. Now let's do a couple more questions. How about 85/9? What mixed number is equivalent to 85/9? Okay, so how many times does 9 go into 85? You're right, 9 goes into 85 9 times. 9 times 9 is 81. And we have to get to 85, so 85 minus 81, there's 4 left over. And so we're going to use that as our numerator. So it'd be 9 and 4 ninths. Notice the ninths stay the same, because that's how many equal parts our whole number is separated into. And so we can even check our answer. We can do the hook and go backwards to see if we can get back to this improper fraction. So 9 times 9 is 81, plus 4 is 85. 85/9. Okay, how about 57/7? How many times does 7 go into 57? Yes, 8 times. And 8 times 7 is 56. So we're so close, we're 1 away. So 1/7 is what's left over. For tomorrow, what I would like for you to do is complete these 4 problems. The first 2, they are mixed numbers, and I would like for you to change them to improper fractions. And then the last 2 are improper fractions, and I want you to change them to mixed numbers. Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.